All right. The guys, guys. So this one, they're talking about the mean value theorem. And so we have already gone over that. I'm going to go ahead and give you this formula. Where it says f of c times b minus a. And then down at the bottom, there's another box. It's just talking about the areas and stuff like that. We're going to pop down to the bottom box. That's the only thing we got to write on this page and actually show you the formula that we learned. So we rearranged this formula so that it was f of c equals 1 over b minus a, the integration from a to b.
Kurt Spurlock and Dalton Reagan, please go to student services.
Of f of x dx.
Kurt Spurlock and Dalton Reagan.
We're going to do an example. So when you're done, if you have your packet, flip your page. Again, you don't have to write the example down. You have it in your packet. So if you're doing it on notebook paper, just write the work down. You can transfer it over. Get yourself together. Get yourself together. You do not have to rewrite this. I'm just reminding you of the formula. 1 over b minus a to b of f of x dx. So what is our a and our b? What's your b? 4, your a is. So we're going to do 1 over 4 minus 2, the integration from 2 to 4. Your f of x is x squared dx. We get 1/2 times, what's your integration of x squared? And then we're going to plug in 2 and 4. So we would have 1/2 times 4 to the third over 3 minus 2 to the third over 3. And that would give us 28 over 3. And again, those of you that are writing on paper, just staple it to your packet. Don't rewrite it or anything unless you're just a spaz about stuff like that. I don't care. There you go. So very good. Same thing on the next one. It's just a trig function. So what's our first part? 1 over b minus a is going to be 1 over pi minus 0. The integration from 0 to pi of sine x dx. Changes into 1 over pi 0 to pi sine x dx. You could have done all this at the same time. You could have went ahead and integrated and everything else. What is your integration? I'm sorry, I didn't put the x. What is your integration of sine x? So we have 1 over pi negative cosine. We're going to plug in your top one, which is pi, or your b. Minus negative cosine would be plus cosine 0. Leave your 1 over pi. Cosine is your x coordinate at pi. What is that? Your x coordinate at pi. Pi is negative 1, 0. So what's your x coordinate? So we have negative, negative 1. Cosine 0 is on the other side. What is your x coordinate? 1. What is negative, negative 1? Positive 1 plus 1 is times 1 over pi is 2 over pi. Your first fundamental theorem of calculus we talked about yesterday. It was the integration of a to b of f of x dx equals, take the integration, plug in b, minus the integration, plug in a, which is what we just did. And then there's a second theorem that says if we take this derivative, the derivative of f over the derivative of x is the derivative of the integration from a to x f of t dt. Anytime we have that x on the top, all they're telling you to do is plug in x. That's it. So we change f of t to f of x. And when we see examples, it's really super easy. Next. It says we've already made the first theorem in evaluating definite integrals. In fact, we use the first fundamental theorem every time we evaluate a definite integral. There's one aspect of the first fundamental theorem, however, that involves the area between curves, and we'll go over that in chapter 16. So in a couple weeks or a couple, But for now, you should know the following. If you have the integration from a to c of f of x dx plus the integration from b to c, sorry, c to b, fix it, c to b of f of x dx. Because these two are the same, the top on this one, the bottom on this one, you can rewrite it as the integration from a to b of f of x dx. All right, so these next couple are really easy. The second theorem, the second fundamental theorem of calculus tells us if we have a constant on the bottom and a variable on the top, the only thing that we do is change our function to have the variable x. That's it. So constant on the bottom with a variable on the top, just interchange your variables. So what would the next one be? We have a constant on the bottom, x on the top. That's it. Just change out your variable. All right. So then this next one just says any constant will give us the same answer. So we had a 1 in the first one, a 2 in the bottom one. If we do d over x, the integration from 2 to x, 1 minus t squared, no, t cubed, doesn't matter, dt. If we change that constant, -2 to the x of 1 minus t cubed dt. If we change it to even pi, and then your x, 1 minus t cubed dt, all of these are all going to equal 1 minus x cubed. Doesn't matter what the constant is. That's all it's saying. So whatever that constant number is, if there's an x on top or a variable on top, you're just plugging that variable in. All right. Second, if the upper limit is a function of x instead of just plain x, we multiply the answer by the derivative of that term. So what it's saying on this one, if you have d over dx, and instead of just x, you have x squared on the top. So this is the same thing, except for I made x squared, which is a function. Then you're going to plug in your function. So 1 minus x squared cubed. I plugged in x squared for t. And then you're going to multiply by the derivative. What's the derivative of 2x? I mean, x squared, I just told you. 2x. So then this would simplify to 1 minus x to the 6 times 2x. So if it's a function, take the derivative. Now we're going to do a couple of those. These are really quick. They're not bad at all. Everybody got this one? We're good. All right. We have 3x to the 4th at the top. So all we're going to do is put that 3x to the 4th in for t. So we have 2 t's in there. So 3x to the 4th plus 4 times 3x to the 4th squared. Is everybody okay with the plug-in? And then you're going to multiply it by what's your derivative of that function? 12x cubed. That's it. You don't have to simplify it out. Just leave it like that. What? You did? Okay. If you need them, let me know. All right. Find the average value of 1 over x squared on the interval from 1 to 3. So we went back to average value. That's the mean value theorem. How did we do that? 1 over b minus a. What's our b? Minus our a is from 1 to 3. And I'm going to go ahead and change it while I'm writing to that x to the -2. Since it's on the bottom, I'll pull it to the top. We get 1/2 do the integration of x to the -2. X to the -1 over -1 from 1 to 3. And then we're going to plug in. So we get 1/2 3 to the -1 over -1 minus 1 to the -1 over -1. I know that you can simplify and reduce that. I'm not worried about you doing that. When we finish, we'll get 1/3. It's just the process that you need to know, and the calculator is going to be easy. Find the average value. We're doing it again of sine x on the interval from -pi to pi. So what do I start with? What is your b? Minus, what's your a? Which will change that into what? Plus, so it'll be 2 pi. From -pi to pi of sine x dx. We're going to have 1 over 2 pi. What's your integration of sine x? Negative cosine x from -pi to pi. So negative cosine pi minus negative would be plus cosine -pi. What is your x coordinate at pi? Pi is on the left, -1. So -1 would be +1. What do we do if it's -pi? What does that mean if we do negative radians? Pull your bow tie. Yeah, it's like stuff on. Yeah, there you go. Yep.
I can't see it.
That's what I'm telling you.
Right.
Well, what is a negative pi mean? Try. Not change the sign. What? Nope. Nope. There you go. You go the other way around the unit circle. So does it matter though with pi? No, because either way we go. So if we have a negative, sorry, if we have a negative, that means we're going to go clockwise instead of counterclockwise. So if you guys see like -60, go from 360 backwards. Does everybody understand that? So pi is not a big deal because either way it's halfway, so it's not huge. So at negative pi, so we went clockwise, what's your x coordinate? We just talked about this. On the left, what's this coordinate? -1, 0. What's your x coordinate? -1. Perfect. What happens inside? 0 times 1 over 2 pi. Still 0. All right. So if we look at the next ones, we have those integrals from 1 to x, and the last one is 1 to x squared. Remember on the first one, just because we have x, we're just plugging it in. So change whatever variable you have in your equation or your function and put the x in. So what is my answer going to be? No dt. What's it going to be? What's up there? What number? What number is up there? 1. The only thing we're going to change is what? The t to an x. That's it. What's the difference in problem 3 and problem 4? So we're going to plug in the x squared, but then we have to multiply by 2x. That's it. So instead of being 1 or t over sine t, t is going to change to x squared over sine x squared, and we're going to multiply it by 2x. This gives you 2x cubed over sine x squared. Bless you. Accumulation functions. It says, suppose we have the function, there's your x, again, 0 to x of t dt. Let's evaluate this at different values of x. First, let's find f of 1. Graphically, we are looking at the area under the curve from 0 to 1, so it looks like this. So why did we do that? Again, we made x 1. So f of 1, we made x 1. We're just looking from 0 to 1. What shape is that? A triangle. What's your area of a triangle? One half base times height, base height over 2, whatever formula you like is fine. So 1/2. What's your base of this triangle if it goes from 0 to 1? What's your height going to be? Yeah, if you think about it, your variable is x. So it's 0 plus 1 or 1. So what do we get? Sorry, ran out of range. If we evaluate the integral at f of 1, we get the integration from 0 to 1 of t dt. What's your integration of t? And we're going from 0 to 1. When we plug in 1, we get 1/2. When we plug in 0, we get 0. And that gives us our 1/2 that we've been looking for. Then it says, let's find f of 2. We're going to do that on the other page. So you can go ahead and flip. This is like one little section, and then we're flipping again. So it shows you the picture. It stretches that triangle from 0 to 2 instead. F of 2 is just the area of the triangle. Area equals 1/2. How far is our base? What's our height? Still 2. Still 2. 2 times 2 is 4 times 1/2 is 2. If we evaluate the integral at f of 2, we're doing 0 to 2 of t dt. Just like we did on the other page, t squared over 2 from 0 to 2. We're going to plug in 2. 2 squared is over 2 is 0 squared is over 2 is, which gives us 2. We can see that as x increases, the function increases. This is a fairly simple example. Let's do another one. So it gives you the function from 0 to x of sine t dt. It says, obviously, f of 0 is going to be what? How do you get that? Let's try it. How else could I get that? How did we get it up here? How did we get 2? We did the area formula, but we also can do what? We can do that integration, right? So let's pop down here and do some integration. Integration from 0 to where? What are we plugging in? F of 0, right? 0 to 0. Sine t dt. We had a kind of formula for this. We'll talk about it in a minute. What's your integration of sine? Kelly? All right. At 0. At 0. What is your x coordinate? So we're doing negative cosine 0 plus cosine 0. At 0, it's 1, 1, 0. Cosine 0 is 1. What happens here? So if we go from 0 to 0, if we go from 1 to 1, if we go whatever, that's going to be your answer. Okay. So then it says f of 0 is 0 because there's no area under the curve. So first, let's find f of pi over 6. Graphically, we're looking for the area under the curve. We're doing this on the next page. Which way? Huh? Oh. Good. Ooh. Okay. Looks like one day. Integration from, where do we start? 0 to pi over 6 of sine t dt. You said that was negative cosine t from 0 to pi over 6. Again, know that unit circle. Pi over 6. What is your x coordinate for pi over 6? Square root of 3 over 2. So we're going to do negative cosine pi over 6 minus negative cosine or plus cosine of 0. You said your x coordinate for pi over 6 right here was square root of 3 over 2, but we're going to do a negative square root of 3 over 2. What's your x coordinate at 0? 1, so plus 1. When we throw that in our calculator, we get 0.134. That's it. Then we're going to do f of 4. We're going to do it on the next page. Sorry, f of pi over 4. We're almost done. Told y'all it would be long. We're going to do the same exact thing. If you guys are okay, I'm going to shorten it up a little bit. We're going to get negative cosine t from 0 to pi over 4, which means we would get negative cosine pi over 4 plus cosine 0. Why is it plus? And minus negative cosine. Okay, I just want y'all to understand why I keep putting plus. All right, back to my cheat sheet. Pi over 4. What's your x coordinate? We're going to change it to negative square root of 2 over 2. Your x coordinate at 0 is 1. When I put that in my calculator, I get 0.293. It says, let's make a table of values of the accumulation function for the different values of x. So we already did 0. We found out it was 0. We did pi over 6. That was 1 minus the square root of 3 over 2. We just did pi over 4. They're writing it backwards. It'll be 1 minus square root of 2 over 2. I'm not doing pi over 3, pi over 2, or pi, but I will tell you that is going to be 1/2, 1, and 2. We can see that the area is accumulating under the curve as x increases from 0 to pi. Naturally, the values will shrink as we move from pi to 2 pi because the values of sine are negative. Okay. Let's do one more example. It has all this work. We're doing it on the next page. I'll tell you what everything is, so don't stress about it. And this is it. This is the last problem, and then I told you we'd be done. So if we evaluate the integral, we get, they wanted us to do f of 1. So if you go back and read the problem, it says do f of 1. They said from 0 to x, we're doing 0 to 1 of t squared dt. Integrate it, we get, we're doing that from 0 to 1. Plug in 1, what do we get? 1 cubed is, divided by 3 is just 1/3. You could do 0.3, it doesn't matter. Plug in 0, 0 cubed is, over 3 is, which gives us 1/3. If you do that for 2, you're gonna get 8/3. If you do it for 3, you're gonna get 9. And if you do it for 4, you're gonna get 64 over 3. That's it. Any questions? Understand why I wanted to finish it. Like I knew it was gonna be really quick. So thank y'all for bearing with me. I appreciate it. I'm gonna post this on our Canvas so you guys will have it if you need it.
Are we gonna turn this